There we are, back at the Azure Tao channel with our MVP Tao Young and the principal consultant for infrastructure on Azure, Ahmad Abdalla. Welcome both.
Hi, everyone.
Thank you. Hello, everyone. Thank you. Thanks for having me.
Yeah, it's our pleasure to talk about Bicep again. We had some videos here with Tao comparing Terraform and Bicep. People love that video, Tao. We had videos with CAF framework for Terraform with Arnaud. And let's go deeper. We have PS through with Benny before about the testing. And we have been working last months, I think, on those new Bicep models. And yeah, Ahmed is going to deep dive a little bit on that. And it's a project called CARML. We're going to show that. And yeah, what's your impression? Welcome to the channel. And yeah, tell us in like 30 seconds what you're going to see there, what people can expect for this presentation.
So, so first of all, thank you for having me, and I'm really excited to kind of to join and talk about one of the open source projects that I've been heavily involved in for the past probably year and a half now. So essentially we call it CARML, so the Common Azure Resource Modules Library. So I would love to kind of come in and kind of share our experience and kind of deep dive around how it works behind the scenes and some of the components that actually are all put together to form out to end up having modules that we produce and we make available to the Azure community worldwide.
That sounds good. What do you think, Tao? Have your questions ready?
Yeah, I just want to mention Bicep modules, right?
Bicep modules.
Bicep modules,
Bicep
yes.
modules. Just in case everyone hasn't used that before, those libraries are specifically designed for Bicep, the Bicep modules.
Yeah.
Yeah.
So in part of CARML as well, we also have our own built compiler that essentially translates the library from Bicep to ARM. Oops, hang on, give me a second. So essentially that compiler is used to kind of make just to help compile all the different Azure modules that we have and just move them from Bicep to JSON templates, just to kind of allow customers who prefer usage of JSON to continue having that experience as well.
Yeah, I like the translation. I like to not lose what we have done before and try to convert and keep improving.
Yeah,
that sounds good. Yeah, you can share your screen and let's go for it.
All
I
right.
have questions. I remember following this from the beginning when we focused more on ARM and Terraform before and then start moving to Bicep.
Okay, can you see my screen?
Yep.
Okay, so I will go off camera just so that I don't kill my PC's performance. All right, so let's kick off. So essentially, CARML, the Common Azure Resource Modules Library. So essentially, it is a library of cohesive, usable Bicep-based building blocks, right? That allows customers to deploy Azure resources. So it is completely built on Bicep. So if you are not across Bicep, so essentially it's a DSL language that was built as an overlay on top of Azure Resource Manager JSON templates. And then it allows a much simpler user experience into declaratively defining infrastructure as code. And helping customers who are not used to kind of using JSON templates to kind of straight away tap into Bicep, which is a much simpler user experience, as I said. So CARML also includes its CI framework, so it has its own engine to help test and validate and deploy modules. I'll definitely dig into those in a bit more detail. And we also support both GitHub Actions and Azure DevOps as well. So the whole value proposition and the goal of CARML essentially is to enable that consistent solution development and delivery. So it's opinionated in how modules are structured and defined, and it kind of applies those principles and concepts across all the different modules inside the library. And we try as much as possible to kind of keep alignment to the Azure template reference documentation as well. So, and one of the key benefits that we've, that we aim to provide with CARML is giving that baseline foundation of, those building blocks so that customers can quickly, grab a couple of modules and start building out their own solutions as fast as possible without having to spend time, and building and testing those modules. Because if you take it out of the CARML main branch, it's guaranteed that it's tested, validated, and it works with all its parameter combinations. So the library itself essentially is, we started off developing this library completely basing on the Azure resource reference documentation. So essentially we start off by the resource provider, and then we did drill down into the resource types, and then we drill down into child resources. So as you can see here, like for example, we have the service bus here as the parent namespace, and then we go into the the child resource type, which is namespaces, and under that we have the child resources of that particular resource type. So authorization rules, you have disaster recovery configs, and so forth. So we try as much as possible to incorporate all the different child modules of a particular Azure resource. That way, we provide the options, that for customers who would like to use the top level resource, but also customers who would like directly targeting the child module as part of that as well. So we have over 100 top level resource. This is pretty much an old number. Now we have way more than that. So this is growing over time. We have many contributions from the community as new modules. Tao as well has been a pioneer in kind of helping us out, and with getting updating our modules, and also a contribution of new ones as well. Yeah, so this is what we talked about. Now,
I have a quick question there, Tao. What's your experience, contributing for the project, and what do you say for people that just copying the code from there or branching from there? How they can get started and help with this as well, I think is one thing going to help as well. We want people to contribute.
I'm not going to lie. The first time I contributed was a bit frustrating, only because because I forked the module, forked the whole repo into my own GitHub account, and because I'm not contributing directly to the Microsoft repo, I can't use the test infrastructure they've already set up. So kind of the most time-consuming part for me, for the first time was to trial and then to figure out what exactly I need to set up in order for the test and the validation to run. But it definitely got better over time after a few PRs. I kind of knew exactly what they're looking for, and that the process became a lot quicker. And I know that Ahmad has reviewed some of my PRs before, and I was cursing at the time, but it's all like a learning process for me. It's I have to say the test framework they've developed is very comprehensive. They're not only just looking at the technical aspect, like even for example, when you do create like a description for a parameter, you have to finish the description sentence with a dot. If you're missing a dot at the end, the test will fail. So very impressive, all the tests that the CARML team has built right now. So
yeah, look, I must say it's definitely a similar feedback we had from others as well. So the thing is, you know, in order for you to kind of contribute to CARML, you would have to also set up your own CI, you know, which is branched out of CARML. So we've written comprehensive documentation to kind of help, you know, the community to kind of get up to speed as fast as possible in building up, you know, their CI environment. Now, it is sometimes challenging where, you know, for people to spend time reading documentation. We're trying to make this as simple as possible. A year ago from now, actually, it was way worse. Like, you know, you had to, there was a settings file that you have to kind of update and put information in that so there's not conflict. We've definitely implemented like a token replacement service, and that things that you could define in your GitHub, you know, variables that would feed down into your CARML, you know, variables inside your tokens. So we're trying to improve this over time. It's definitely hard for most people to kind of get it up and running, you know, quick enough. But as Tao mentioned, like we are opinionated in the tests that we have to make sure that there's a, you know, a standard user experience where all the modules that get produced. Like for example, if the module is if the parameter is optional, you don't provide a value as an optional inside the parameter definition, the pipeline will fail because it sees that you've set it up as optional, but you're not providing an optional value. So we try to make sure that we have a consistent, you know, cookie cutter approach that applies to all modules. And when Tao was contributing, like I definitely smashed him, I think, with over probably 50 comments and suggestions in his PRs. But you know, it's for the better good for everyone who takes those modules, you know, out of the, you know, next day. They will know that it's a CARML based module. It works. It's got all the CARML standards into it. Yeah,
I think that's the message. Don't give up. If you try before to help and didn't work well, try again. The framework's getting better, the support, the testers, and there's always a reason to do that. Like you said, it's to provide a better quality of modules and the framework, and be more reliable, you know, not like short term, but medium, long term as well.
Yeah, and also like we're currently working with the Bicep engineering team on some upcoming you know, publishing for our modules to the Bicep registry, the public Bicep registry. And one of the POCs that we're going to look into is actually how could the Bicep public Bicep registry README generator also benefit from the information that the CARML README, you know, enforces and applies as well, like the examples that we use, the parameter usages and whatnot. So there's definitely a lot of learnings, and we hope to kind of share this with others as well.
That's cool. Let's go ahead. I want to see that.
Okay. So yeah, with regards to a support policy, so definitely, so CARML is a Microsoft open source initiative, and we want people to kind of you know, use CARML to kind of help them get up to speed as quick as possible in building out their own Bicep modules. And so there are scenarios where there is a scope of support. You know, examples if you're, you know, having issues with resource providers or you know, template errors or internal server errors that sometimes you get out of a particular resource that's not related to CARML. So definitely those, you know, you would want to kind of continue to use Microsoft support for that. You can also open up a support ticket with Microsoft with regards to a CARML module, but, you know, they will end up, you know, referring you back to the GitHub repository. So you could definitely open up issues there. The CARML team tries, you know, hard to kind of always respond as quick as possible to community feedback and feature requests and bug fixes. So we, you know, and we definitely appreciate support from you know, for the global Azure community to kind of help, you know, keep this as a consistent experience for everyone and make it the best. So in its simplest form, right, there's two kind of components to CARML. Right, there's the resource modules and there is the CI environment. Now, the resource modules are just the building blocks that are used to construct solutions. So your storage account, your key vaults, and whatnot. And then we have the actual factory that actually validates and makes the building blocks available for users to construct those solutions. And the good thing is that we've embedding the whole CI engine and the resource modules together, so that if customers would like to take the entire CI environment and internally into their, you know, into their environment, and, you know, allow them, you know, to have, you know, dedicated teams to manage modules centrally for the organization, you could absolutely do that. So you could take the entire CI, manage it yourself. There's definitely patterns of how you could keep up to date with the CARML changes and and synchronize with them. But we definitely encourage customers to not only just take the modules because they work, but actually you could even use the CARML engine internally to kind of help you manage your own inner sourcing library capability as well. So the resource modules are primarily developed in Bicep, right? So that is the language that we use as the main language to deploy modules and test them. It is a building blocks for cloud solutions, as I've said earlier. We have strong alignment to the ARM reference documentation. So we even have tester tests in our pipelines that detect if the module API version is outdated for a particular, multiple API releases. We actually start failing this module, and it automatically creates GitHub issues so that we can uplift the API version. So that way, we don't stay far behind from the latest APIs from the resource providers, and also we are able to add more parameters and features as we go on as well to make those available. So the documentation of the resource modules is quite comprehensive. So it covers all the different parameter combinations. It sorts them out from what's optional, what's required, what's conditional. It provides parameter usage scenarios, so how to use a particular object input. It has examples, so we even publish our own tests into the README in both Bicep and JSON as well. So that's kind of like if someone just looks at the README, they have full coverage of what to expect in a particular module. We have a lot of work to do down the track to integrate the user-defined types in Bicep, and so that it could help us, provide more information and guidance of how to use object type parameters, because those are abstracted in a way that it's not visible to the user of what is inside that object. What do I need to provide? So we're heavily going to rely on that user type when it becomes GA'd. So and then that would actually simplify our documentation as well. Now, in terms of our CI environment, so we are fully supporting both GitHub Actions and Azure DevOps Pipeline. So every module gets tested, in GitHub Actions, but we also have the Azure DevOps version of that particular module as well. So that pipeline, so that for customers who would want to use inside their own inner source environment, they rely on Azure DevOps, for example, they could continue to use Azure DevOps Pipeline. For customers who would want to use GitHub Actions, then you definitely could just take on the GitHub Actions. So so that's two full supported versions. A heavily comprehensive static validation. So that's where all the pain is. Essentially, is all the work that's done to make that consistent experience for CARML. And then we have module validation and deployment, so that there's multi-stages that we have to validate a module across different combinations of parameters. So that goes from a minimum type. So for example, what is the base minimum to actually get this module up and running, to the absolute, heavily configurable parameter sets, so that, like with private endpoints, with customer managed keys here, with user identities and a whole different combinations. And we also have a modules publishing and versioning kind of engine, and that helps us publish modules outputs to be consumed by other pipelines in different ways, which I will drill into in a bit more detail. All right. So so not going to repeat a lot of what I already said, but this is, for example, this is an example of a storage account module implementation. So every module has child resources, right? Or most modules have child resources, and those child resources essentially are also embedded into the main module itself. So an example would be, you could deploy an Azure storage account, but you could also deploy a container part of that same storage account deployment. And what we do in CARML, we treat child modules usually as an array, because most resources support multiple types of the same child module deployed. Like SQL Server can have multiple databases, storage account can have multiple containers, Key Vaults can have multiple secrets, for example. And then we also have extension resources that's also embedded into the module. So an example here is to use the locks. So if you would like to deploy a module and also directly lock that resource, right, you could do that absolutely, with the same module. You want to create RBAC permissions to that module. You can also do that within the same module deployment. And if you want to do diagnostic settings as well for the deployment, that's also embedded part of the modules. In addition, some modules actually have this concept of cross-references, and which is even published in our documentation. So, for example, a storage account or an Azure function or a Key Vault could support private endpoints. So what we do basically, instead of having this private endpoints embedded into every module, we actually centralize the private endpoint deployment module, and then we make it available to all different modules to use. So that's what we call cross-references. And we actually provide that information in case someone wants to extract this module. What cross-reference module does it rely on in this library as well? So that, if you want to take the storage account alone, you'll definitely need to take the private endpoints module as well, because we rely on those different modules. So,
a quick question on this one. I think that's where the things become more, complex, is with the cross-reference things. The version that you're applying there is for the whole module. The child is all the same version of the storage account module there.
In terms of API?
Child, in terms of the deployment and release, it's all the same version of the module.
Yeah.
But the cross-reference could be a different version.
Yeah. So the cross-reference module can be on a different version. But essentially, we reference them when you want to consume, let's say the private endpoints. Okay, if you want to consume the storage account module, from your Bicep registry or your template spec or whatever other mechanism, the compiled version, right, of that essentially is already embedding the other module into it as well. So like the private endpoints. So it takes whatever version that you define in your in the storage account module, and it would just use that. Now this becomes much simpler once these modules are published, right? So that then you could rely on the published version of that module, right, which is and reference that version number as well, so that you can control the version.
Yeah, and you try to test, let's say I have private endpoint for storage account, means that I can keep, increasing the numbers of storage account that probably change more often than private endpoint. But how your tests work, like are you testing multiple versions of private endpoint with the new versions of the storage account? Let's say storage account go for version 1.5, and then maybe private endpoint, you have, the last two versions. How your tests work? Are you testing multiple versions to see if anything breaks?
So let's say the private endpoints module is on version 0.5, right? And our storage account module is at version 1.0, but it's using 0.5 for private endpoints, right? Now, let's say that we've released a new private endpoints module. Now it's 0.6, okay? Now the storage account module is now at the moment, right, is still using 0.5, right? Now because it's in the same, if it's in the same repository, right? If it's the same repository, the moment I start compiling and testing storage account, it will already take the latest version of the private endpoints module. If I am actually not using that method, so if I take this inner source and I would instead use the published version of the private endpoint module, then I would be able to statically say, 1.5 is still using 0.5 of the private endpoints module until you test it out with 0.6, and then you move the whole module of what the storage account to 1.6 that uses the 0.6 version of the private endpoints.
Well, but it's probably the ideal solution, to lock the numbers to make sure that you don't break in one.
Yeah.
And now we always think that, like in big companies, you have multiple different projects, and each one of those projects could be using different versions of the modules.
Yeah.
And you make sure that,
I think this is the same as like another language that I hate to say the name, but Terraform is the same, right? You can specify that using the latest version, or you can pinpoint a version that you reference.
Yeah.
But that capability is already built into Bicep.
Yeah. What I see sometimes is like, let's say you want to deploy a VM and you need a storage, and then you're going to use the storage model on the VM module. And then there is a new feature normally on let's say, storage account that is a dependency for VM. Now you always need to go for the latest version if you want to release like a new feature. It's kind of
I think it's
how to document this is the problem. How to make it sure that everyone understands the cross-reference and what's going to break what.
So that's where the README comes very handy. Like we in a Bicep or you can use the CARML. There's a capability to statically generate the README file that will have all the parameters and outputs documented. Or if you're not using that, there's another option from our friend Bernie White. It's called PS Docs. It does the same thing. In the generates README files for Bicep or for ARM templates. So it's a matter of it's just a matter of reading documentation on what are the inputs and outputs.
The README is a very important piece of the puzzle, specifically in the deployment examples, because when we do our tests, we are also publishing our test inputs into that README as well, because we want others to see how we are using certain parameter combinations in order that fit into the input of a particular module. And there are some modules, and if not most of them, are heavily, in a common scenario of a deployment, you'll see massive usage of different parameters. That's not even in the documentation as well, in the public documentation, because some of that information is not there, unfortunately. So we actually, like if you look at the Dev Test Lab, for example, module, there was so much effort that we had to do in order to get all the different combinations of a Dev Test Lab deployment with all the different inputs combinations, with all the possibilities that had to be tested out in order to actually get a full end-to-end deployment of a Dev Test Lab service fully through infrastructure as code. So, and these things definitely take a while.
Yeah.
That's amazing that, the testing framework there, I think that's the most valuable thing of all of the framework, because you're making sure that you're testing different combinations. And if there is a break change, let's say, we don't recommend use private endpoint version 1 anymore. The minimal version should be version 1.2. Then you can put this on the README and make sure that nobody's going to be using our old version, or even make sure that it's on the documentation. It's amazing.
So the structure of a file, essentially, I think we've done that before, but I'll just drill into a little bit more detail. So this is what the current module folder looks like today. This is going to change in the future, just as an FYI. So we are working with the Bicep engineering team on publishing our modules into the public Bicep registry. And there is some alignment that we have to do in order to kind of get our modules in a shape that is, compliant with the Bicep engineering requirements. So, for example, we're going to be dropping the Microsoft dot in the resource provider name and just stick to key vault. And we're going to move from camel casing for the resource type name into like kebab casing. So it's going to be lowercase kebab casing, where you've got key and you've got storage and then dash accounts, for example, instead of one word with camel casing. So the folder itself in here internally, what we're also going to be changing is the main deployment, the core deployment file. So today we call it deploy.bicep. We're going to move it towards what's called the main.bicep, and I think that's more of a common naming, that exists in the community today. I think it's even used in Terraform, if I'm not mistaken. But that's
that's right.
Yep. So
that's the first thing I change every time I fork copy a module from Bicep from CARML, is changing the name to main.bicep.
Good. Okay, so that's going to come in soon. So the first folder here that you see is the .bicep. This is where we store our extension resources. So, for example, if we're doing an extension deployment of for a module for role assignments, this is particularly where we store those child resource or extension resource types. The .test here this is pretty much one of the most important folders that we have. This is where we have those different combinations. And as I mentioned, like common essentially deploys most of the parameters inside a particular module. Min essentially deploys the minimum required to get a module up and running. PE, for example, tests a module with private endpoints. So some modules have 5 tests, some modules have 3, some modules have 1. It just depends on the module type. And then this is where you could see the child resources. So the child resources like vaults, access policies, keys, secrets are child resources of vaults. So and every module in here is also treated as its own entity. So I could simply take only access policies by itself and just give it the key vault name, and then you could deploy it in isolation. So you do not actually need the parent. We publish using our publishing mechanism. We publish both the parent and the child, so that they both have separate versions as well, so that you can version them separately in your own repository.
Okay, they have different versions. That was my first question before.
Yeah. But not for the cross references, the one that you talked about. So this is more for the child resources. So I could definitely publish a version .0.5 for access policies and continue to have 0.4 for my main key vaults. But obviously, if I'm uplifting the child module, I also want to be uplifting the parent as well, so that it incorporates all the different scenarios and combinations of the child module. Yep. And then you see the deploy.bicep I just talked about, the core file. So this one here calls all the child as an array, so that if you want to deploy multiple versions of those, multiple resource types. And then that's the README. So the README essentially is also published for the child modules, and it's also published for the main module as well. One important note here is that we do not test the child modules in isolation. The way we do that is by applying all the tests in our common scenarios. Because in order to test every one of those separately, we would probably need hundreds and hundreds of pipelines and publish in a separate way. So what we're doing actually, our main module here, because it calls all the different children, we actually make sure that we test them part of our deployment. So if someone like either a maintainer or a contributor wants to add a particular feature in, let's say, access policies and adds a new parameter, this must be tested in the common, for example, because that's where we want to validate this bit. So the sequencing of event in CARML is the development phase, which is where you go in and evaluate and deploy and test modules, right? And then we publish. So once the modules are developed, they're tested, they get published, and the publishing outputs could be your own private Bicep registry, your own Azure DevOps universal packages artifacts, or you could actually deploy those to template specs, so that you could actually have customers who want to use template specs, for example, instead of Bicep registry. And then, which is that last phase here is the consumption phase. So how does it all work? So as we said earlier, so we have the develop modules phase. So this is the CARML repository. You go in and start writing your pipeline for a particular module. You have your own sandbox or your to kind of validate and test modules. So the first phase is to write the code for a particular module. That pipeline performs that static validation. So it goes in and runs the entire pester suite against the module. This now actually incorporates PS rule, by the way. So we've recently enabled PS rule inside our modules testing. It's at the moment, it's in audit mode. So which means that we're not blocking anything that comes out of PS rule, but we are using the telemetry or the data that comes out of it to improve our CI and our tests. But then we're going to start adding more features into how do we actually align to the PS rule recommendations. Deployment validation, so that the part of the module gets deployed and validated inside your Azure subscription. So all the different combinations get deployed separately. This was so a long time ago when actually CARML first started. We had persistent resources that was always there, like the dependency resources. But then the team has worked very hard essentially to enable that self-isolated deployment. So every module gets tested and deployed with its own dependencies in isolation. So a new resource group gets provisioned for the common, for example, and it deploys all the dependencies that are required to get this common deployment up and running. It deploys the module into it, tests it. Once it's successful, it deletes the whole resource group after it. So it's all done in isolation. So there's no more dependencies on other modules or long-lived resources, essentially. Once the module is done and tested, it gets published, and that publish and endpoint could be your Azure Universal Package. It could be inside your template specs library. So you could have a resource group that contains all the different template specs, and then you essentially publish those. So as you add more modules, your library increases. And then the last phase, which is the consume phase, which all the different solutions can start consuming whatever the modules that you have. And I think essentially that's it. So that's kind of it on a very high level.
That sounds amazing. This last picture here, and one thing I saw that if you miss the PS rule and you don't know, we have a video here with Ben White from Microsoft about this. And another thing you said at the beginning was the inner source development. Looking for this picture here, the inner source will be on that
on the left side.
On the left side here.
Yeah. So
you're pretty much going to fork this. Can you like?
Yeah. So customers, for example, can absolutely fork CARML as it is and chuck it into their own repository, right? And their own system, source control system, and then they could actually build and publish those modules internally. Because what happens is customers would have requirements for things that they don't want to expose to their other developers, like or hard code certain scenarios that they don't want to make as optional. So because CARML is generic, what customers can do, they could actually overlay on top of CARML essentially their hard-coded versions that they publish, right? And that way they don't tamper with CARML's modules because they always want to get the latest, but at the same time that overlay essentially consumes CARML and then publishes to their end developers or application teams and others. So it should also encourage inner sourcing in a way where developers actually are able to contribute back to their inner source library and actually add more modules to that same repository and as well. So how I see customers using this, for example, is you've got CARML on one side, which you don't touch, right? And then you've got your overlay on top of that, which you could create your own combinations or your hard code things. And then this is the one that you publish to your customers. And your customers only interface with your overlay, but CARML is always in the back end here, so that when you want to update CARML or update your modules, you're always kind of, you don't have to deal with, conflicts or folders that you don't want to start coming in and whatnot.
Yeah, that's nice. And if you want to extend the testing as well, if you want to have more testing, in this case, you're not just giving the modules, you're giving like a framework with the whole isolated, testing for each module. I think there's a value on that, like that deployment validation. If they're going to do that in private, they need that infrastructure to be running. It will be like kind of an integration testing. It's not like a unit testing. You need like the real environment, test environment where you can run those things. But for big enterprise companies, I think that's a perfect solution. And
No, I believe it definitely cuts down a lot of thinking, brainstorming, and trying to do it yourself. Like, the team has spent massive effort in trying to uplift this framework and CI system to, for customers, just take it as it is and chuck it inside, and then customize whatever you want to customize on top of that. But it gives you that baseline of, the README engine, the publishing engine, the deployment engine, the validation engine, and so forth. So it's good to kind of start from there.
Yeah, and don't change the baseline. Yeah, normally tell the customers don't change the baseline, otherwise they have to maintain.
Yeah,
it's kind of a create a layer on top. Otherwise, there is a cost for you to maintain that.
Yeah,
and we're doing that on the framework. Just build something on top of that, and that will be less, costly for you to maintain. Just the overlay, the layer on top, then maintain the whole thing.
Yeah, I think
what
also.
Do you think, Tal?
Yeah.
No, Tal, we had projects before with Terraform where that became very expensive and very hard to maintain because we maintained the whole thing.
Yeah.
So
over the last 18 months or so, I've probably done 2 projects where in the customs production environments where I leverage Bicep. Leverage CARML and Bicep. I can say that, it's God's blessing then that we have CARML library that, does like 90% of the work for me. That significantly reduced the amount of development time I needed to develop all those modules for customers environment. I have full respect to the team that dedicated to this. If later on we have time, I can, after Ahmad's demo, I can show you. I can do it, show you like what I'm even using CARML for my lab environment right now, so I can show you what I've done in my lab using CARML.
No, absolutely. Like I think it's definitely useful to kind of see the actual usage versus just modules. So the other day I was at a customer, in New Zealand, and essentially I've developed an end-to-end event-driven architecture that helps, run administrative tasks on enterprise scale. But it's all driven through Azure automation, event grids, webhooks, and so user identities, key vault storage. So it's a combination of a lot of different modules. And I used 99% of the entire thing was deployed through CARML. I did not modify any module. I just used them as is, whether it's child, whether it's parent. Sometimes it's a combination of both. But when I just went in, created my own repository. I took a couple of Lego blocks from CARML, put them inside my library, and then started writing my main Bicep. And I had an end-to-end solution architecture that's just all deployed through CARML. So which I think that's the value I see versus just the modules itself. Like, is how fast can you actually get something up and running, and deployed production grade and tested and validated as well. So
yeah, I think that's my question there as well, because I have worked with cloud adoption framework before with Terraform. And are you planning some kind of guidance on those common scenarios? Like you said, event-driven architecture or something. If you get those architectures and you kind of have a predefined, like sample, or
there are
something that you're planning to do it?
Yeah, there are some accelerators that were developed using CARML as well. I don't have a link to them now, but I'll find them as well and share them so that maybe you could actually put them into the into the actual podcast. But those are actually amazing solutions that were done by different consultants and engineers to kind of go in and use CARML to actually deploy real-world solutions. I think AKS was one of them, and I think there's something on SAP if I recall correctly. But I think I'll happy to share those as well. So the one that I just mentioned, it was purely done because I wanted to solve a particular problem, and I was like, all right, let me do it through CARML. I still have it in my private repository, but I'm willing to actually make this public soon, and I want to share it with the community as well. So definitely on the roadmap.
Do you have some demo there or some code that you can see that?
I do. Yeah, absolutely. I do. So I'll definitely show that today. So yeah. But actually, what I'm more interested in actually seeing Tao's version, because I know Tao gets the module, opens up its guts and takes stuff out of it. So I want to see.
Sorry.
So I want to see how he actually does it as well.
Yeah.
If that survived to Tao, then survived for the customer.
Absolutely. So yeah, like the flavors, as I mentioned before, so we have Azure DevOps and we have we have GitHub workflows. So those are always tested and validated at the same time whenever a new module gets updated. So they're fully working. Our README, so essentially it's written in Markdown. One of our core, maintainers, Alexander, spent so much time also building out the README generator capability. So he's written it through PowerShell, and essentially it goes in and constructs this entire README from scratch, using Markdown, and it converts the module from Bicep to JSON so that we could do objects, interpret, manipulation, extracts information, puts, organizes tables and does all the work. So I think this is one of the most amazing pieces I've seen in CARML, and it's just definitely worth just looking at as well. So yeah, we've got the for example, you've got the key vaults here. We have all the different resource types, parameters, outputs, and template reference. We actually have links to the template documentation reference APIs as well. So let's say if we use the module version, July 2023, for example, we don't have 2023 yet, but July 2022. So you actually get a link inside the actual documentation that points you to that particular API version as well, so that you could have, see more information. And then again, so we also have a converter inside our repository if someone would like to use the JSON version of the module. So that actually goes in and converts the entire repository from Bicep to JSON, for example. Some customers would still prefer to use JSON just because of how they're currently managing infrastructure. But we definitely recommend moving to Bicep, but it's there for backwards compatibility. Yeah, so contributions to CARML. Everyone is welcome to contribute. There is heaps of issues. We encourage the community to always, provide us with feedback. It's very important, that we receive this feedback. We're doing it for the community. So if something is not great, then we want to know about it. So that we can improve it. But yeah, feel free just to go in and have a read through the wiki. There's a very comprehensive wiki that talks about all those different pieces of the CARML module library, the design decisions that we've made, how to deploy, how to even create a solution as well. So there's a solution guidance of how to use a public Bicep registry, also your private Bicep registry, your template specs, your directly modules deployment. So please go through that. And I guess that's it from a slide deck perspective, and I guess we should probably drill into a demo and going through the library in a bit more detail and showing how I actually perform my development activities on CARML and how I test my modules as well. And then maybe we can hand it over to Tao, who could show us a little bit more hands-on view of the real-world usage scenarios of CARML. And I could definitely show that event-driven stuff as well, if you like, after this, and show how all those combinations were kind of built together to kind of form an end-to-end solution. Okay, so I will stop sharing this, and I will switch over to my screen. So give me a second.
I was wondering, when you're doing that, I was wondering if ChatGPT can.
I've already
what
tried it.
ChatGPT
It
can
doesn't
do
work
that.
right now.
It doesn't work with CARML. Well, maybe
No, it doesn't work with Bicep too well.
Oh, so with ChatGPT, by the way, I'm amazed of how this thing can really find out. Like it's pretty good. But it can find wrong. I can write wrong stuff as well. So
I'll share a story with you guys. Customer environment a few weeks ago, there was a requirement to create a lifecycle management policy for a storage account where, like, say after 45 days, move to a cool archive storage, but in another storage account, right? So it's cross storage account. I had a look at the documentation. I'm like, this is not doable. So I can't satisfy these requirements in the design. So the data engineer we work with send me a link and say, hey, this is the link, and then send me a code snippet, say, this is how you implement in Bicep. I look at it and say, where did you get this from? This looks very genuine, but where did you get it from? And he's like, ChatGPT. Can you ask ChatGPT where he got it from? And ChatGPT generated a link to the documentation, which is the exact documentation I read before. And then I read again, say, that documentation never mentioned anything about this capability. So it just made things up.
Yeah, it does. No, it does. Yeah.
Yeah, and our colleague, actually, I'm not going to mention the name, but he actually tried it over the weekend, and in his own environment, now come back on Monday and say, yeah, you are right, it doesn't work. It's not in the documentation. What do you think? It's not going to work.
It definitely did that as well. Like, I actually asked it once to give me a Bicep module that allows you to upload a blob into a storage account.
Yeah.
Right. And it actually wrote me a Bicep version of something, that you could upload a blob to a storage account.
Mm-hmm.
And how on earth do you do that? Because it's data plane interactions, right? So, so it's actually written the whole thing from itself. Like, there's no way that you could actually do that. So, yeah. Anyways, all right. Let me quickly go to the VS Code. All right. So essentially, this is my fork version of CARML. So it's completely synchronized to the CARML main branch.
Do you? Hey, sorry, George. Do you want Ahmad to zoom in a little bit?
Is it too big? Too
small? Maybe zoom in
a little bit more, yeah, if you can.
How do you zoom in on
Control plus?
Control plus.
Control plus. Okay. Okay. How's that?
Yeah.
Okay.
Yeah,
cool.
there you go.
So what I usually do actually is I have this file called CARML.ps1, and this actually helps me do my own testing and development of CARML modules locally. We also built part of CARML a local testing script. So this script actually simulates what a pipeline experience would look like, right? Because imagine if you're developing a change to a particular module and you would want to test it before you commit it to your source control. Even if it's branched, you don't want to wait for the CI to run and then work and then tell you it failed. So what we've done, basically, we've created in our utilities here is a test module locally script, which actually mimics the pipeline workflow. And using this script, you can actually do tester test, deployment test, validation tests. You can inject your own tokens as well into your into the template files, and I use it quite often to kind of test before I even publish a branch. I just make sure that all my modules are working before I even commit it to source control. So this is the basic setup I usually have in my environment. I also have a stage here that does removal. So in our CARML, in the CARML CI, we actually perform modules removal as well. Actually, we should actually integrate this into test local as an option. So we have a removal stage. So I could actually I can mimic the exact same behavior of the removal by running the script locally, which is initialize deployment removal. And then I can actually set readme. So whenever I update a particular module, right, I run our readme tool, right, and make sure that the tool skims through the module again, and it makes sure that all the readme is generated based on my new changes. Because if I don't do that, the CI will pick this up and it will fail. It will tell you that the README version that I have is different to the README version that you have. So, and it will fail, essentially.
Sorry, Ahmad, just a suggestion here, like in terms of regarding to the removal process, can I suggest that you guys make it optional? There's a way for people to disable the removal, because it happened to me like, something wrong with the, the PR that, my PR is failing and the pipeline is failing. And in order for me to troubleshoot, I need to see the exact resources that have been deployed. But it's hard for me because it's been removed at the end of the pipeline. So I had to manually figure out, reverse engineer and disable the removal. So in order for me to troubleshoot, but if it's something that you say.
So we have this as in your test scenarios as well. So when you're deploying from your branch, for example, right, you have the ability to skip certain tests and skip stages. And if you want to keep things, for example, for troubleshooting, this is something that I would recommend switching off.
Yes.
Right. So
that's good.
Okay. So yeah, it is there. Feature done. Go for it. Okay. All right. So essentially, what I'm going to do here is I'm going to go to a module, right? So I'm going to pick here. I've actually pre-prepared what module I'm going to be working with just to accelerate our demo. So I'm going to pick the managed identity user assigned identities module. So what I'm going to do actually in here, I'm going to update this module to actually have another output. So let me copy this output, right? And I'm going to paste it here. And this time I'm going to use different properties. So if I look at the properties, I'm going to now output the tenant ID. So we don't have this as a feature, and I'm not sure if we even need it, but let's just say I want to do that. So I'm just going to say that tenant ID of the user assigned identity, right? So now I have updated my module, right? Before I deploy this, I just want to quickly show you the tests. So in our tests here, usually there's something called dependencies.bicep, and there's a deploy.test.bicep. What we do basically for a lot of modules is that they require certain dependencies to be deployed for a particular parameter combination. And an example here would be, let's say you would like to deploy a virtual machine. Now, the deployment of a virtual machine requires a virtual network. It requires a subnet, right? Now, in order to do that, you need to have those deployed pre the deployment of the actual virtual machine. So what we do in our dependencies here, I'll actually pick a bigger module like the disk encryption set, and let's look at.
Probably need a key vault.
Yeah. So let's look at the disk encryption set, for example. What we do in part of this module, we're deploying a key vault. And what we're doing here, by the way, in the dependencies, we don't use our modules. So we've made a decision to use the public resource directly, right, from the resource provider, bypassing our modules because we did not want to create that dependency. So in this example here, we have to deploy an Azure Key Vault in order to get this disk encryption set deployed. Once we deploy that Azure Key Vault, we have certain outputs, right, and that we take out of this Key Vault, and then we're passing it back to the main deploy.test.bicep. So this is the file that we are testing where we run our deployment, the template deployment. But if you look here, there's a stage here that says, or there's a deployment that says module nested dependencies. And this is where we're deploying our dependencies for that particular module. And then we're taking the outputs that come out of this and feeding it into our modules, because some modules do require this dependency essentially so that you can fully test them. So we make sure that we have a full range of the dependencies deployed before that module gets triggered, and then we just pass in the outputs. So for example, if you're deploying a disk encryption set, you need to specify the Key Vault resource ID, and that resource ID essentially is provided from the dependencies. Similar to other things like the RBAC. So when we test RBAC, we create a managed identity inside the dependencies, and we take the output, the principal ID, so that we could test the RBAC extension resource. In addition, if we want to use user-assigned identities, for example, notice that we're also taking the output here and appending it to the user identities object so that we test this module that also supports user-managed identities. So, and that's kind of how we have full coverage, you know, of the deployment of the different parameter combinations. I'll also show you something way more dense when I mentioned Dev Test Lab as well. So notice that if I do it, so this is Dev Test Lab. This is all the different combinations that you can create inside a Dev Test Lab deployment. So things from shared public IPs to policies to, you know, like allowed number of virtual machines in the lab. Like all this stuff here is not inside our documentation. We had to make the effort to go in and actually test all those different combinations together so that we could actually help customers understand how to even use this module. Okay, so back to our managed identities. So I've added now the tenant ID, right? But I have not updated my documentation, right? So what I'm going to do right now is I'm going to test this deployment of a managed identity. But what I'm going to do, I'm going to actually run tester, but I'm going to skip the deployment. So if I go in and run this bit here against my module, which is the managed identities. So this is mimicking the pipeline stage that does tester test. There you go. So we see that the test failed because it noticed that the set README, right, is different, because what the tester test actually does, it actually goes in and generates the README internally, right, and it compares it with the README that you have here. Like it does, I think, a hash comparison against the file, and if they're not the same, it actually stops you essentially, because they want to make sure that whatever you're sending out to the publishing essentially has to be updated. So what I'm going to do now is I'm going to actually go in and update the README. So we have a tool. All you need to do is just go do a set README and then just pass in the template file, which I already have here for my module. And then I'm just going to go in and generate the README. So
it means the README is always fully automated.
that is correct.
Yeah.
So notice now we have a tenant ID that's just been added here. Right now, if someone, for example, goes in and updates the README manually, right, and let's say they bypass the set README tool, they may end up putting the order of the parameter or the output different to what the README tool generates, because this is ordering by alphabetical, right? If they go in and put the tenant ID at the top, that will also fail. So it's not just about having the actual thing in the README, it's actually having it aligning to the README standards, because the README, the tester tests validate much more than just the structure. They validate, the type. They validate the optional types. They validate the conditional. They even look at the dot, as Tao mentioned as well.
Okay.
So yeah, so once this is done, right, and let me now go in and run that same test again. But this time I'm going to do a tester and I'm going to do a deployment. Okay, I'm going to run this file, imagine if it fails. There you go. So now our tests are successful. So what it's actually doing now, it actually went in and did what's called a token replacement. So this name prefix essentially gets replaced, right? And so that you can generate, so everyone can have their own unique name prefixes, and this is something that they specify in GitHub variables as well. So once this is essentially, it goes into the resource provider, it starts deploying the module. So if I come here, we should see the new resource group get created now. No, I'll just look at the deployment. There you go. So it's saying user assigned identity, common, and we have that naming standard. If I go to the resource groups now, I can see that the resource group got created. And now the deployment is actually testing. So it's actually deploying the dependencies first, making sure they're all there, and now it goes in and deploys the module. So notice what are the things that we're testing here. Yep.
So you can basically map each of the module in your template into a deployment here, because once you deploy that Bicep template, each Bicep module becomes a nested deployment. So you can always like map it.
Yeah, absolutely. So part of our common test, we also do a lock as a deployment onto that particular resource. So if I come back now to my resources, I've deployed all the resources related to this module. Notice that if I come back to my actual identity, I could see that the lock has also been created. So once this is done, now it's time to remove it, right? So I could use, like in part of the pipeline, like this is something that's going to be automatic, but usually when I want to clean things up, I want to go in and remove that deployment. So I just copy that name here and then pass it on. And then I just quickly do a remove. So these are all scripts created inside the library as utilities to kind of help developers, have the full experience of the workflows and the pipelines right from inside a local development environment. So notice that it's what the first thing it does, it goes through a sequencing event. So this is definitely another massive effort that was done by the CARML team to actually build this functionality of deleting resources. So it goes into the order around how the module was deployed, and it starts removing all the different resources under it. Sometimes it could take 10 minutes depending on how many dependencies the module has or how many things it deployed. But essentially it goes in sequence and it starts essentially just removing the module before it finishes off. Now that concludes the deployment stage. Would you like to see this happening inside the CI pipeline inside GitHub, or should we switch over to Tao to tell us more a little bit about the real world usage?
Let's quickly show like just maybe
CI?
Just
CI
one thing, Tao.
Yeah.
Just one thing, that if someone's going to use that as it is, they don't have to do that. Yeah, just to make sure people understood.
Yeah.
If they use the baseline directly without making any customization, they're just going to consume from the public repository that will be available soon.
Yeah.
Is that correct? Yeah.
Yeah, correct. I think what Ahmad's trying to say is that this is the test, that this is the testing processes have gone through before any updates to the module have been published to the main branch. Yeah. So you can safely assume that everything that you copy or you borrow from the main branch has gone through this set of tests.
Yeah, what I mean is, if someone looking for this framework just to consume as like a baseline module, they're not developers. They're not going to help us to improve that. They're just going to consume.
Yeah, they're definitely usable just by copy and paste or just leveraging. Then you can literally just take a copy of the code and then run with it.
Let me show what I did here. Just a second. Can I share my screen?
Yes, please. Yeah.
Let me share my screen. Can you see that?
Yeah.
That's my ChatGPT on Azure Portal. I have Azure OpenAI service. That's what I call Azure OpenAI Studio. I just have ChatGPT 4 that probably is in preview and most of people don't have access yet.
Can you increase the font a little bit?
I can. And as you can see, I'm using GPT-4.
Yeah.
You could be using 3.5. I'm pretty sure it'll be fine. Now I have ChatGPT inside Azure OpenAI Studio. And when you presented there, I was just in play here, and look what I did. I asked ChatGPT, can I use, that's the repository for the resource modules, that's correct? That's the one? Or?
Yeah, that's right.
I said, can you use that repository to generate a Bicep script to install AKS Azure Kubernetes Service? And then he gave me do like a git clone from the repository, go for the AKS module, and then if you can run locally, like not using pipeline here, it's just referring the local, module without like a repository. And then he created it and showed me AZ deploy, group, and template file. Is that correct?
Wow.
That's pretty good for the starting, but I hope the AKS
Okay.
deployment is that simple.
Then
but
I asked, let me go on. Then I asked, can you add 3 node pools on the script? And he added like 3 node pools.
Wow.
And he even explaining, in this example, it's another 3 additional node pools parameters. He's explaining what he's doing. Okay.
Wow.
And then I say, can you set node pools VM to use a 4 cores and 16 gig? I haven't said the name of the VM. I just said 4 cores and 16 gig. And he picked like a standard D4 SV3.
Hey, I wonder if this is like really working, like, because to be honest, like this is amazing. Like, if this actually like uses.
Hang on, let me keep going. Let me show you. And I said, can you use a key vault using CARML module and linking it with the AKS cluster? He created a key vault and link it here with the key vault ID.
So I think this is where it's wrong, because
resource ID, right?
So a couple of things. So the thing is, if you look at first of all, the modules/key vault is actually modules/microsoft.keyvault/vaults. That's the first thing on the path. And then you have the key vault name. I think what we're doing in CARML, actually, the name, it should always be name. So it would never be key vault name until you're using unless you're using the child resource. So
and it's main.bicep, not deploy the bicep. Here you go.
Okay, let's see. I'm just showing, and then I asked, can you get the preview script from AKS? Then he got the preview script with the node pools, because the other one wasn't including node pools. And I just said, can you get from the previous AKS script? And he got from there. Is that key vault name is now correct, or no?
Should be name. Should be name.
Should be key vault name here.
Yeah, look, I think it's making stuff up in a way as it's going. But the point is, I think, is that it's incredible that it can actually make this stuff up and be confident about it as well.
I'm just saying that things are going better and getting better and better.
Yeah.
Look, if we give the right context, if we give an example with, let's say, I can ask him to fix. I can say, is this one that's wrong?
No, it's the actual
name. No, the module for the key vault, it should be name.
Yeah.
Oh, okay.
Yeah, so it should be name.
Not the key vault name.
Yeah.
Okay, should be name. Yeah. Okay.
So definitely it's
And
maybe let's revisit this in 12 months time and see if it improves it.
Yeah, but I'm just saying, he said the CARML is maybe not included there, but I think maybe it is, and then wow.
Yeah, I think like, you know what, the other day I used I tried to use ChatGPT, actually Bing Chat, to actually do this. Hey, like, go skim through a subscription using PowerShell and find me all the key vaults that are standard and convert them to premium. And then it did it. And then I asked it, make sure that you validate that they've actually been converted after you change them. And then it did it. And then I said, make sure you disable public network access for all key vaults as well. And it actually did it, which is pretty good. And then I said, make the subscription as an input, right? And it went in and gave me a read host, right? Mm-hmm. And I said, yeah, and I said, no, that's not the right way. You should make this as a parameter. And it actually came back and said, you know what? You're right. It's best practice to use parameters instead of read host. Here's the updated version with parameters. And I took that and I just went in and checked this out, and it actually worked. Like, the whole thing actually worked.
So it's learning from you as well.
Well, yeah, of course. But I
You're
think
pretty sure that you can use Copilot because Copilot uses GPT-4 already.
The
And
new
GitHub
version.
Copilot, you can ask the same thing. If you give the right, prompt for GPT, he's going to give the right answer. And but yeah, you have to fix small things, but the massive code will be done if you ask everything that you want, and you just validate quickly that if it's right or wrong.
you have to know what you're talking about.
Yeah.
Yes, you
that's
have
the
to
most
understand what
important.
you're
So
talking
we are
about.
not out of the job yet.
Not yet. It's just to be more productive. Just say, if you quickly want to do that, and you get that, and just make sure that everything's okay.
Yes,
but that's just the beginning of GPT. Imagine in the future. But Tao, what do you have there? What do you want to show?
Let me share my screen.
I don't want to be too long this video, but hang on there. If you're watching, Tao is going to show what he has done.
Go for it.
Hold on. Let me. Why is it asking for my password?
I double dare you to have a Metallica background on your laptop.
I wish.
That's his password. Hashtag Metallica.
Metallica.
In case you didn't know that, I'm wearing a hat, Metallica hat, and a T-shirt, like for the Metallica's new album. But there you go.
Yeah.
Can you guys see my screen?
Yeah.
Yep.
So I've done this a couple of times in customers' environment, and obviously I'm not going to show the customer's code, but I over the last couple of weeks I've been redoing my library environment using Bicep and the CARML. So this is the repository I've got in Azure DevOps. I've got this folder called modules, and this is mimicking the folder structure where same as CARML, right? Grouped by the Azure resource provider. And for example, Azure Networks, you have all these resources for the Azure Networks. Virtual networks, we'll have private endpoints, we have service endpoint policy, which is something that Azure CARML is missing. If I get time, I'll probably raise a PR later.
Just saying. Yeah, you can do that.
I can do that. One thing I want to mention, something that I did differently. So firstly, let's compare the very common module like for the VNet. This is the one that we have for from CARML. So most of the CARML modules has all the diagnostic settings built in here, which might not be required for some customers' environments. Most of the customers I've worked with use Azure Policy to deploy diagnostic settings. And also, all the modules in CARML has got this default collects telemetry, so it deploys this resource. And there's also some resource logs and some nested role assignments for some of the resources. So, but in order for me to straight away leverage the CARML module, normally what I do is I copy this and into my repo, and then I get rid of the things I don't want. For example, the diagnostic settings, because I will never use that in the module. And then I'll just save it and to a name that I prefer, like main.bicep, and start leveraging that in my Bicep template. Another example I have is that, for example, Bicep private endpoint. When I first start using, creating stuff like about 9 months ago, 10 months ago, when I first developed this module, the customer I worked with at that time had a specific requirements. All the private endpoints will have a statically assigned private IP address, and I have a Azure pipeline. As a part of the Azure pipeline, I actually calculate what the private IP is. Say, for example, I have a storage account in this environment. Will have the number 5, the fifth usable IP in that particular subnet, my pipeline will calculate what the exact IP is, and then pass that to the template when I use that module. So I've created a parameter called static private IP address, and so if it's not empty, and then use that. So I have put a logic scene, which like at that time that I think CARML didn't have that particular capability. And when I developed this module, but it does now, but it's still it's a bit different. In order to create, like for example, in order to create a static IP address, that you have to specify this IP configuration. So for someone, so just if I put my hat on as like a consumer or customer who is going to leverage this module, it probably doesn't know that what are the the payloads, or what are the the properties I need to put into this IP configuration. So it's not very obvious for the customer who leverage the module to know that in order to create a static IP for the private endpoint, you need to construct this IP configuration parameter, which is is not very obvious. Maybe when the user assigned user defined objects comes in over the time, this one will be more clear. But at this time, it's not that very clear. So
you're 100% right.
Yeah. So this is the reason that it just make it more user friendly for the customer. I create this parameter in here to allow people to define a static IP address. So, but in terms of
like question there, question there. Like, have you thought about creating an overlay on top of the CARML module versus updating the module itself? Like, would that be? Yeah, so maybe like, for example, if you create an overlay that actually exposes static private IP address in a way for your customer, but keeping the CARML one as is, because if the customer wants to update the CARML module to add more stuff in, to do it,
that could be that could also be a way to go. But just keep in mind that every module that you end up like calling in your Bicep template, like this is the template, it becomes a nested deployment. I also ran into an issue in this particular solution I'm building in the previous engagement I worked with, is the payload, the ARM deployment request, the payload actually exceeded the limit of 4 meg. So when this Bicep module that I've developed that compiled to ARM is over 4 meg in size, and then they failed because it became too big.
It's definitely an issue we've heard about before, and I think it's one of the issues that the Azure Landing Zones team also faced as well when they were testing on some of this module stuff, and they've even I think a lot of people are facing it, even if they're not using CARML. You still actually end up hitting this limit, and it's unfortunately something that we can't control. But the way I tell customers, for example, if your template is very big, it's good to deconstruct it now into having separate tasks anyways, rather than having one big bang, because it makes it easier for you to even test in isolation versus trying to always test big bangs.
So another modification I've done is that, for example, the role assignments template, you have all the building roles defined like as variables, like map the name with the actual resource ID. They're just like hundreds of them, right? But if you if you think about like in your template, if you can create like 10 role assignments, which what I've done is probably more than 10, this nested resource template, whatever you have in here, like this is actually a lot more than 10, a lot more than 100, like it's probably about 300 something. It's going to duplicate all this code 10 times. So in order for me to reduce the number, the size of the size of the deployment template, I had to remove this and then remove this capability, and then just by have to pass the resource ID into this module, but with not using the building role names. This name and the resource ID mapping is nice to have, but it just can have performance impact.
I agree with you. No, I agree with you, and this is pretty much a decision around should we even support having names or not. But what we've noticed, many people don't like to use IDs as well, and they're like, it's unfortunate that
it's got its place, right? So for a smaller environment where if you deploy, if you're developing a simpler templates, then that's perfectly fine. But just for me, that because
I totally agree.
My template when I compile the Bicep to ARM was like over 40,000 lines in JSON, and that's something I just had to give up in order to shrink the size of the template. So that's the first thing I did. So this is kind of the modification I've done in order to make it working in a very complex enterprise environment. But other than that, but the CARML module has done like probably about 95% of the work for me. But when there's something's missing, for example, the service endpoint policy, what I just mentioned, just a matter of raising a PR and then contribute what's missing in the CARML.
Yeah. Let's do one thing, Tao. I think that's nice because you helping the project, how the project works.
Yeah.
And then you come out and you change the modules. I understand that the best way probably be doing overlay. We could maybe come back here another day just to show how to do like an inner source, so how to create overlay. We can organize another time and maybe showing that as an end user that need to create like 1 or 2 overlays and deploy something. Get like one use case, a simple one, where you have to do overlay and show how they can do that.
Definitely, let's do a part 2.
Yeah, let's do a part 2 later and do that. And I'm excited to bring on the next one the updates on ChatGPT and see how that GPT-4 can maybe help with Copilot. Maybe we can try Copilot as well. And now I have Copilot X, that's a new version that's coming, that's going to be able to see your repository. Then Copilot X, there's a new version of Copilot on GitHub, will be able to see the context of your code. It means that they're going to be able to see your scripts, your previous deployments, and learn from that, and then propose updates based on everything that you wrote before. I think that's the next level, probably.
That's exciting and scary at the same time, right? Because like I think if we just take 2023, like the word AI, has just definitely been the catchphrase for this year, right? It's and like it's just moving so fast. Like I love it, but I'm scared of it at the same time. Like how much can I expose my kids to it? Like, is it too early? I'm
No, we're fine.
Right. My daughter is already using ChatGPT to write essays.
Oh, there you go.
We're going to learn that. Like if you're watching, if someone's watching this video in 2025, you're laughing from us.
Yeah.
We have no idea what's going to happen. And that's going to happen. Let us know when you watch these and you'll be laughing from us.
Yeah.
But that's going to happen for sure. But let's have a segue for this thing. Thanks a lot for joining. I think it was amazing. And I'm excited with these, evolutions. And it's all, guys, about giving options. If you are Terraform, a cross-plane, that's fine. There are use cases for each one of the frameworks. And I think Bicep with those modules and those frameworks to inner sourcing is amazing. Is what people should be looking for. And for sure, we keep improving. You can help us to improve.
Yeah, I agree with you. Look, from my perspective, and as I always say this to developers and engineers, is that choose the tool that makes you productive and meets your requirements, right? There's good cases for Bicep. There's many good cases for Terraform, Pull on Me, Crossplane. I didn't even know Crossplane did Azure infrastructure until now. So I think, I'll just always leave it to developer teams to always decide on what is the best tool that meets their outcomes. And just use that, right? It's always a team decision. As long as people are empowered to make these decisions and choose what's best for them, I think that's how it should be.
And especially like Ahmad, for you and me, you consultants, we normally don't always get the luxury to choose the tool that we want to work with. We just choose, we just have to use whatever the customer is using, right? So
the tool chooses you.
Yep.
Yeah. We now also have Azure Service Operator that's like a CRDs on AKS, on Kubernetes, that you can also create things. I mean, we have options. You have to pick the right one.
Yeah.
And I think this one is a very good option, to be honest. And that comes from the experience that we had with our templates. All these building blocks is something that we have been playing for years, and now it's coming for that.
Yeah, absolutely. And
revolution.
And it's free to use, so why not?
Yeah. Okay, thank you.
Right. Thanks, everyone.
See you on the next one with ChatGPT 25.
Part two.
Yeah, absolutely. I look forward to actually having another session, and we could drill into it a little more realistic scenarios with deployments, and we could talk about overlays as well, and how you could expose things differently to your end customers and whatnot. So yeah, let's definitely keep that on our roadmap.
Yeah, for sure. And if you're not subscribing to the channel, please hit the subscribe button and follow us, and you're going to get notification for the next one. Thank you, everyone.
Thank you, everyone.
Thanks.
You.
See you next time.
See ya.